Today we will do question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Hint is given. Let x be any positive integer, then it is of the form 3q plus 1 or 3q plus 2. Now square each of these and show that they can be rewritten in the form of 3m or 3m plus 1. Here in this question, you can take any positive integer. So it is not given as even or odd, nothing is given, any positive integer. That means you can take any number. Here, let a be any positive integer. Let it be odd or even, anyone, and b equals 3. By Euclid's division lemma, we know that a equals bq plus r, where b is 3. And r's value is greater than or equal to 0 and less than 3. That is, r's value lies between 0 and less than 3. R's value is 0, 1 and 2. So we can write like this. A equals, b's value is 3. So we can write that 3 here. 3q plus r. Now r's possible values of r are r equals 0, r is greater than or equal to 0, so r equals 0, 1 and r's value is less than 3, so 2, till 2. These are the possible values of r. Now we have to put the values of r in this equation. First we can put, when r equals 0, a equals 3q. When r equals 1, a equals 3q plus 1. When r equals 2, a equals 3q plus 2. Now in the question, we are asked to show that the square of any positive integer is either of the form 3m or 3m plus 1. So we have to find the square of this positive integer. So we can square both the sides. Let it be 1, 2 and 3. So first we can square equation number 1. That is, a square equals 3q square, which is equal to 9q square. Now we have to write it in the form of 3m. So I am going to take 3 outside. So this will come 3q square. So we can write this as, which is equal to 3m, where we are writing it in the form 3m because we want to write it like that only. It is in the question, where m equals this one. M equals 3q square. It is given in the question that for m is some integer, where m is some integer. Next we can square equation number 2. A square equals 3q plus 1 the whole square. Here you have to use a plus b the whole square, which is a square plus 2ab plus b square. 3q square plus 2 into 3q into 1 plus 1 square, which is equal to 9q square plus 6q, 3 2s are 6 into 1, 6q plus 1. 1 square is 1. Now this also we have to write in the form 3m plus 1. So from these two we can take 3 outside. So this will come 3q square plus 2q plus 1. We can write it as, take this as m. 3m plus 1, where m equals 3q square plus 2q for some integer m. Next we are writing like this because we have to make it in the form 3m plus 1, like that. Now the next equation we can square. So a square equals 3q plus 2 the whole square. This also you have to use a plus b the whole square. A square plus 2ab plus b square. 3q the whole square plus 2 into 3q into 2 plus 2 square, which is equal to 9q square plus 3 2s are 6, 6 2s are 12. 12q plus 4. Here in this equation, if we are taking 3 outside, it will come 3q square plus 4q plus 4. But in the question, we are asked to write in the form of 3m or 3m plus 1. So, we have to split this 4 like this. 9q square plus 12q plus 3 plus 1, because we need to write in the form plus 1, m plus 1. That is why we are splitting this as 3 plus 1. Now we can take 3 outside. So this will come 3q square plus 4q plus 1. We are taking 3 outside from this 3 plus 1. We can write this term in the bracket as m. 3m plus 1. So we get 3m plus 1, where m equals 3q square plus 4q plus 1. In the question it is given that m is some integer. Therefore, we can write square of any positive integer in the form 3m or 3m plus 1. See, here it is 3m. This one we write it as 3m plus 1. This also 3m plus 1. Like this. Next question number 5. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Let's see how to do this. Here also it is given any positive integer, so odd or even anything. Okay. Let a be any positive integer and b let it be 3. We can take 9 also, no problem, but if you are doing with 9, our calculation will be very lengthy and you have to take the cube. Then cube of 9 will be a large number, so it will be difficult for the calculation. If you are taking b as 3, then also you can show it in the same form 9m plus 1, 9m plus 8. When we are taking the cube of 3 and taking the common number 9 as outside, you can take it as 9 as common as outside. While doing the problem, you will understand it. Let's see how to do this. So by Euclid's division lemma, we know that a equals bq plus r, where r's value is greater than or equal to 0 and less than 3. Therefore, the possible values of r are 0, 1 and 2. If you are taking 9 here, the possible values of r will come as 0, 1, 2, 3, 4, 5, 6, 7 and 8. So you have to do a lot of steps. So for avoiding that, we are taking it as 3. Now we can substitute these values in our equation. Therefore, a equals, when r equals 0, a equals 3q, b equals 3. 3q plus 0, which is equal to 3q. Let it be 1. When r equals 1, a equals 3q plus 1. Number 2. When r equals 2, a equals 3q plus 2. This is number 3. Next we have to find the cube of this equation. So first one, a cube. First we can find the cube of equation number 1. A cube equals 3q cube, which is equal to 3 cube is 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 27 q cube. Now we have to write it in the form of 9m or 9m plus 1. So this one there is no plus, so we can take 9 outside and the remaining will be 3q cube. We can write this in the form 9m, where m equals 3q cube. Next we can cube equation number 2. A cube equals 3 cube plus 1 the whole cube. Here you have to apply the formula a plus b the whole cube, that is a cube plus 3a square b plus 3ab square plus b cube. This formula you have to apply. Then this will come as 3q the whole cube, that is 3 3s are 9, 9 3s are 27. 27 q cube plus 3 into a square is 3 3s are 9, q square into b 1 plus 3 into a is 3q into b square is 1 square, that is 1 plus b cube 1 cube which is 1. So 27 q cube plus 9 3s are 27 q square plus 3 3s are 9 into 1 9 cube plus 1 cube is 1. Now from this you have to write it in the form of 9m plus 1. So here plus 1 come. Now we can take 9 outside from the other terms. Take 9 outside. So from 27 we can write 3q cube plus here also 3q square plus here q plus 1 which is equal to 9m plus 1, where m equals 3q cube plus 3q square plus q. And the third equation, a cube equals 3 plus 2 the whole cube. Here also a plus b the whole cube, that is 3q the whole cube plus 3 into a square, 3q square into b plus 3ab square. 3 into a is 3q into 2 square plus b cube, 2 cube, which is equal to 3 cube is 3 3s are 9, 9 3s are 27. 27 q cube plus here 3q square, 3 square is 9, 9 3s are 27, 27 multiplied by 2, 54 q square plus 3 3s are 9, 2 square is 4, 9 4s are 36. 36 q plus 2 cube is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Now we have to show that it is in the form 9m plus 8. Here plus 8 already come. So we have to take 9 outside from these three terms. Take 9 outside. So this will come 3q cube, 9 3s are 27 plus 9 6 are 54. 6q square plus 9 4s are 36. 4q plus 8. We can write it in the form. Take this as m. 9m plus 8, where m equals 3q cube plus 6q square plus 4q. Therefore, we show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8.